Hey everyone, welcome back to Let's Unbound, and we are in our AP Precalculus series, Unit 3 Trigonometry Functions and Polar Coordinates. And yes, we are in the 13th episode, which is all about trigonometry and polar coordinates. So let's get into this without any delay. So first, let's understand what is trigonometry and polar coordinates. Trigonometry and polar coordinates are closely connected. First, what is polar coordinate? This will represent points. We know coordinate geometry. We learned about points x, y, 1, 2, like that. Polar coordinates is also a way of telling a point where we will use two things, of course. One is radius and other is angle. Radius is the plane, like radius is the distance from the origin, and an angle theta instead x comma y. So polar coordinates will be p or comma theta, and rectangular coordinates, like the point will be represented as x comma y, right? And polar coordinates, as I said, it's quite different from rectangular, also known as Cartesian coordinate. R is the distance. So this is how there is a pole here, and it's not like lines, it's like circles. Can you see it? There's mild line, right? And everything is one radius or 0.5, like how we take skip counting. Sometimes we will take x-axis as 1, 2, 3, other times 5, 10, 15. In such a way, we can pick that. And angles are mentioned at every spoke. The main spokes are this, right? 30, 60. If you want to do for minute angles, yes, you can do that too, right? This way, these are the major spokes and the angles are mentioned. So if you know the angle and the radius, you can mark it. For example, you need an angle of 30 degree and radius 2. So if this is radius 2 and 30 degrees here. So 2 comma 30 degree. Got it? So that's it. Even in radians, we can do that, not only in degrees. Now, when your r is greater than 0, r is radius, of course it will be greater than 0, but sometimes r will be negative, like that will be a convention. Okay. So point is r units from the pole, angle theta from the polar axis, right? So from the pole, I should move r units. If it's less than 0, negative means it is on the line theta, but in the opposite direction of the pole. So I will just move away from the pole. For this, I will move in the opposite direction. So theta means what? It's an angle measured in radians or degrees, and the way we have to measure is counterclockwise direction from the positive x-axis. You can see the thin lines like x-axis line. Okay. So that's it. And now, rectangular coordinates we know. So how to manipulate polar coordinates and apply concepts while problem solving algebraically. So any point P of x comma y, it's what we say, it's a Cartesian coordinate, right? So you just drop down a 90 degree, like drop down a distance. So you make a right triangle. If this is theta and this is x, this is y, we know this already. X is r cos theta, y is r sin theta, and this is your radius r, right? So the horizontal segment from the origin. So these things we will use for converting from rectangular to polar coordinates or polar to rectangular coordinates. These things will help us, right? So yeah, they are interrelated. Your rectangular coordinates and this polar coordinates are interrelated. We are just showing it how they are related here. Now, finding the modulus r. So in polar coordinate, I need r. Modulus means distance, okay? And r is square root of x square plus y square. This is the formula. Finding theta, I will use these. X is equal to r cos theta, y equal to r sin theta. I will use this and manipulate. I will apply that ASTC rule and all the reference angle, all those that we learned in the very beginning of this unit. Okay, that's the way I will find r and theta. Then I found the polar coordinate. And one more thing, the polar coordinate is not unique. So in our Cartesian coordinate, if I say 1, 2, it's 1, 2. It doesn't mean anything. But polar coordinates, it is not unique. So one coordinate, like one point, can be represented in multiple ways, right? So keep this in mind. And with this, we are moving into our question solving. Plot the points whose polar coordinates are A1, 5 by 2, and What is given? Yeah. B 2 comma 7 pi by 6. So first you have to go to pi by 2 here and 1. It's positive, so you can just directly go towards, you just move towards your angle. Okay. This is your A point. And B point. 7 pi by 6. So 7 pi by 6 is here and it's 2. So I will mark 2 is the radius here. So this is first radius, second radius. So this is my B. Right? That's simple. Now, what if I give you negative, like negative 3, 7 pi by 6? What will you do? 7 pi by 6, of course, it's there. But on that pole, I will move opposite to that. 1, 2, 3. Okay. So this is what? Minus 3, 7 pi by 6. I will move away from that 7 pi by 6. Okay, this direction. Right. And how this is possible means 7 pi by 6 is just if you sub like 2 pi minus 7 pi by 6 will give you 12 pi minus 7, 5 pi by 6. Right? And then you can do 5 minus 5 pi by 6, which is 5 by 6. So this way it is connected. 2 pi minus 5 by 6 if you do, like they are just lie on a straight line over there. Right? And the point is not unique. And now convert the second problem, convert the point from rectangular to polar coordinates. So how to do that? For polar coordinates, you need r and theta. How can I find it? So if this is x and y, the r formula is square root of x squared plus y squared. Right? Square root of minus half square plus minus root 3 by 2 square. Square that minus by 1, minus 1 by 2 will become 1 by 4. This will become 3 by 4. 4 by 4 is 1, which is 1. So r is equal to 1. And x is equal to r is 1 cos theta. Okay, what is my x? My x is, so we know this. I'm just using this, maybe the convention. For finding angle, use this technique. X is r cos theta, y is r sin theta. And I know all x, y, r. So only theta will be the remaining. So let me do. R cos theta, r is 1. So I will get cos theta is x is minus half. Sin theta is minus root 3 over 2. Right? So where both of them are negative, cos is negative, sin is also negative, this place. Right? So this, whatever angle, you can write it as pi plus theta. This way we can write. And here we go. So what it would be? Okay, theta is cos inverse 1 by 2. It's just a reference angle, so I'm not taking the sign. So theta r is when cos will become 1 by 2 at 30 degree or 60 degree, 60. So let's go with, I'm going with radians of pi by 3. So this is just reference angle. It lies on this place. So third quadrant. So actual theta is pi plus pi by 3, which is 4 pi by 3. And hence the coordinate is 1 comma 4 pi by 3. This is how we converted what we say. So this one, the rectangular to polar coordinates. Hope this makes sense. And moving to the third problem, the last one. Convert the polar coordinate to the rectangular coordinate. So how to do this? Again, that x is equal to r cos theta. X is equal to r cos theta. Y is equal to r sin theta. Right? And you can just plug in the things you know. X is equal to r is 4. This is r theta, right? 4 cos 5 pi by 3 and y is r sin 5 pi by 3. So 4 cos 5 pi by 3, I can write it as 2 pi minus pi by 3. Okay. So this way here also same, y equal to r. Okay, what is r? Actually, we know r, right? I didn't do that. So r is 4, right? So 4 sine 2 pi minus 5 by 3. So 4 cos 2 pi minus theta is, it is 2 pi minus theta's quadrant is cos quadrant, so it will be positive cos pi by 3, and y will be 4 negative, because it's this angle lies on fourth quadrant, their sign is positive, sorry, negative. So sine pi by 3. And you know the standard value, 4 cos pi by 3, just now we did, it's 1 by 2. So 4 times 1 by 2, which is just 2. And y equal to minus 4 sine pi by 3, it's root 3 by 2. 1 times 2, 2. So y is negative 2 root 3, x is 2. So that's it, we have 2 comma negative 2 root 3. This is the rectangular coordinate for the given polar coordinate, right? And that's simple, this 3.13, and yes, we will do more on polar coordinates in the upcoming episode. So yes, I have a bonus question for you, and yes, take a screenshot, try to solve it on your own. It's simple, basic, but still it's an essential skill. So make sure you're trying that and you're practicing it. Thanks for joining today. And if you want to join Let's Enroll Student Community WhatsApp group, you can scan the QR code given here so that you can be in touch with Let's Enroll and its updates. So if this video really helps you, you can consider subscribing to Let's Enroll. Thank you for learning with us. Keep learning and keep practicing. Stay curious.